So in this example, you see we are given a hoist that supports a 125 kg engine. And due to this engine, you see at point G, a force is acting vertically downward. And you see at point E and C, we have pin joints, so two reaction forces are acting at, and at point A, you see we have a roller joint. When we have to find the forces in the members FB and PD. So uh, you see we are given the mass, so let's take this part first to find the force in the member FB. So you see, if I extend uh, the member FB and the coordinate axis at point P, you see it makes about a right angle triangle. So in order to find this angle, I use tan inverse theta, which is basically equal to perpendicular over hypotenuse over base. So this is our perpendicular 3 meters and base 1 meter. You see, when I apply moment at point E, this is our moment arm. So the remaining values is the mass of the engine, that is 125 with the force of gravity 9.8 and the perpendicular is 3 meters. Negative, I have force, which is the member FB acting multiply. I have sine with angle 71.5 and the perpendicular is 2. So I get the force in the member FB, which is 1938.87 Newton. So you see, to find the force in the other member, we have to uh, find the reaction force, say that point E. So when I take Y component, so I get the force at point E in Y direction, which is about 613.12 Newton. And when I use the X component, so I get the force at point E in the X direction, so which is about 613.1 Newton. You see, the forces, these two forces are similar. Okay, so let's find um, the force in the member PD, which is about 2601.27 Newton. So how can we find this force? You see, these are the forces acting, and we have already find the forces that are acting at point E. And you see at point B, we have a right angle triangle, and its angle, you see, we can find by using tan inverse theta. So when we apply moment at points, if we get this equation which says we have negative FBD because it is moving in clockwise direction, multiply we have its horizontal component cos and an angle 45, which is this. We can find this angle by using this equation, and it is about 1 meter, and we have 613.12 Newton force, that is the force acting at a point E, and we have minus 3. You see, this force is basically the X force that is acting in the X direction. So, this we can find the force in the member BD, which is this force, which is 2601.27 Newton.